We now want to consider a particular type of probability distribution called the binomial distribution. So binomial probabilities come from binomial experiments, which have four qualities. First of all, there are a fixed number of trials, we'll call it n. You have only two outcomes, we'll call them success and failure, and success is whichever one you're interested in for the question that you want to answer. The trials need to be identical and independent, so the probability of success from one trial to another should not change. It should be independent. And then your probability of success equals p. We're going to use lowercase p. That is the same for all trials. So these are actually related to each other, those properties. And then we will sometimes also use Q as the probability of a failure, and Q is going to be 1 minus P because success and failure are complements. So complement probabilities have to add to 1. And our random variable CAPAX is going to be the number of successes, and that is a binomial random variable. So let's verify this for an example. Suppose that 70% here of airline flights in the US are on time. We're going to consider 3 randomly selected airline flights and record the number of those flights that arrive on time. Is it a binomial experiment? So are there fixed number trials? Yeah, we're going to choose 3 flights. 3 trials, which is fixed. So that one works. The trials have only 2 outcomes. Success is going to equal on time. And failure is going to be a late flight. So only 2 outcomes. If you're not on time, you're late. Are the trials identical and independent? So we'll assume here that these are not connecting flights. Okay, so we'll assume not connecting, and in that case they'll be independent. They won't depend on each other because they're just any randomly selected flights. So we'll assume that they're not connected flights. And in that case, they'll be independent. And then probability of success should be the same for all trials. They tell us success is on time, and probability of being on time here, they told us was 70%. And that's for any randomly selected flight. So that one works. So yes, this is indeed a binomial experiment. So if you look at the probability distribution of the number of flights that are on time, that's going to be a binomial random variable.